Welcome back to this plenary session in GRA6036. We're now to do exercise age. In this exercise, we are to fit this regression model on the whole dataset and compare it to this regression model that contains these interaction terms. So notice that this model here is nested inside this model. That means that if you set beta 4 and beta 5 equal to 0 here, you get this model. Then we're supposed to test this hypothesis. So the null hypothesis is that beta 4 and beta 5 are equal to 0 versus the alternative that at least one of them is different from 0. So we are, this hypothesis is the same as saying, so we're testing this model against this model. So our null hypothesis is that this simpler model without interaction terms is true. So to test this hypothesis, we can fit the simpler model. So let's just copy this code, call this fit age, and remove the interaction terms. Then we have it, we fit this model, and now we can use the ANOVA function and take fit age and fit f into this function. And we get this output, and the important part of this output is this p-value right here. So the p-value is 0.1245, and we see that at the, for example, at the significance level of 5%, this means that we do not reject the null hypothesis. So the conclusion of this test is that we keep on believing that the simpler model is true and that we don't need to include these interaction terms, or said otherwise, that the effect of experience is the same across the two groups, the good-looking and the not so good-looking group. So this might be puzzling because if we go back to this big model and look at the summary, we see that both interaction terms are significant. But notice this p-value and this p-value, they are testing whether or not this coefficient is equal to 0 versus the alternative that it's different from 0. This p-value is the p-value test that's testing whether or not the coefficient on here is equal to 0 versus the alternative that is different from 0, while the hypothesis we're now testing is a different hypothesis. The hypothesis is that beta 4 and beta 5 are 0. So we're not testing the same hypothesis, and naturally we don't get the same answer. So the answer, I mean, in a way, the answer we get here is at odds with the answer we get if we look at the individual tests. But yeah. Okay, so now assignment 2 is in assignment 2. I strongly advise you to, and we've sort of done some of it already because we used the sequence function and made plots. So I'll put out a script where I do it, but it's no need to me to make a video about it, I think. And so the important part is to understand that so the plot function is plot x, y, and use type L for line to get a line instead of dots. And now for this to make sense, x must be a vector of values. So if you want to plot something smooth and nice, we can make a sequence from something. So say minus 4 to 4 by, and here is a step length. So this is then from 2, and then the step length, let's say we take step length 1, then x will be this, 1/2. It will be the steps of 1/2, 1/4, we get this, and so on. So often it's just nice to choose a small number so you get something smooth when you plot. And now when you have so now you have to make your y. So let's make x x 1 plus exp x 1 half 1 half. So now we have an x and y, and we can make a plot. Now we have the power mf row. We have to adjust it back 1 1, and here is our plot. So let's try to plot this instead, so we don't get something so like this. So what you do in this assignment is to make, well, try to plot different functions and see how they become smoother when you decrease the step size. So I mean, if we here, for example, drive this up to 1 half, you'll see that we'll get something not as smooth. So let's go even further. 1 will be even less smooth. You can see it's linear between the points we have on the x-axis, but we're not able to see that when we drive down the step size. Okay, so well, thank you, and we'll talk on Thursday.